Hi everyone. So this is the last topic for the module B, and we are doing races. So basically races are of two types. One is linear race and the second one is circular race. And apart from that, there is a very small and very interesting concept called as clocks also that we are going to explore in this particular topic. So let's start with linear races. As usual, the name suggests people will be running in a straight line, and there are certain statements whose interpretation is very crucial. So first statement is this: A gives B a start of 10 meters. Now what does that mean is that A will let B run for the initial 10 meters, and after that A will start running. So that is the meaning of A gives B a start of 10 meter. Now this start can be in terms of time taken also. For example, they may say that A gives B a start of 10 seconds. Again the same interpretation. A will let B run for the first 10 seconds and only then A will start running. So first two statements are from the perspective of the starting point. The next two statements are from the perspective of the finish line. So the statement is A beats B by 10 meters, and look at the language. A beats B, yani A has won the race. A is at the finish line. So A is at the finish line, A has won the race, and B is still 10-meter away from the finish line. That is what the interpretation is. Now the same thing can also happen in terms of time taken. For example, they may say A beats B by 10 seconds. So same interpretation, A beats B, yani A has won the race, A is at the finish line and B is still 10 seconds away from the finish line. So that is the interpretation of this particular statement. The last statement that you should be aware about as far as linear races are concerned is basically a dead heat, and this may be new thing for people. So dead heat in simple words that it's a tie. That means both of them reach at the same time. That means both of them finish the race together. That means both are winners. So dead heat is basically in simple words it's a tie. So these are the different types of statements that you may have to analyze, yeah, that you may have to know the uh, meaning behind. Only then you will be able to solve the questions easily. The second part is basically circular races. Now circular races, as usual, there can be two scenarios. One is people are running in the same direction or people are running in the opposite direction. We are exploring the first type when people are running in the same direction. Now observe very carefully, when do they meet for the first time? So the race has started. When do they meet for the first time? And it will be very interesting for you to know that this is where they meet for the first time. And the point that you are supposed to always remember is that if it is a circular race and if they are running in the same direction for the first meeting, one simple point that you should be remembering is that the faster runner always takes a lead of one lap over the slower runner. If you analyze properly, A has covered only a quarter of a lap, whereas B has covered one full lap and covered another quarter of a lap. So effectively B has a lead of one full lap over A. So faster runner always takes a lead of one full lap over the slower runner. Now let's continue the race and then let's observe when do they meet in the second particular meeting. The race is continuing and they meet at opposite to starting point, which is basically a 6 o'clock position. So for this particular point, what you can obviously understand is A has covered another quarter of a lap, whereas B again completed one full lap and covered another quarter of a lap. So effectively so far B has a lead of two full laps over the slower runner. Sorry. The third meeting obviously opposite to 1 o'clock because it has to be the symmetric point, which is 75% completion of the race, which is a 9 o'clock position in a way. And the fourth and the last meeting will happen back at the starting point. Something of this sorts from where they had actually started the entire race. So some of you people might have some more questions about this, that why are they meeting in only 4 points? Are these going to be fixed every time? Is this changeable? If it is changeable, how does we come to know? And so far and so on. So yes, it is not fixed every time, and it is decided by the ratio of the speeds. So for example, in this particular example, what we had assumed is earlier that both the runners A and B, they are having the ratio of the speeds as 1:5. So the point that you are supposed to remember as far as circular races are concerned, if it is a same direction wala race, in how many points do they meet? So they meet in 4 different points. And how do we get that 4 different points? We take the difference between the ratio of the speed. So difference of 1 and 5, that's how we get the 4 different points, and they have to be 4 symmetric points, and hence starting point, then first meeting, then second meeting, then third meeting, and then back at the starting point, the fourth meeting. So 4 distinct points is given by the ratio of the speeds, so difference between the speeds. And also remember, whichever is going to be the last meeting, in this case it is the fourth meeting, that meeting will always happen at the starting point. So there are only 3-4 pointers that you should remember. Circular race, same direction. For the first meeting, faster runner will have the lead of 1 lap over the slower runner. Who decides how many points? Ratio of speeds decides. The difference of that decides how many points. Those have to be the symmetric points, and every last meeting happens at the starting point. In this case, it is the fourth meeting. So that's all about same direction. Suppose if it is the opposite direction wala race, and again observe very carefully, when do they meet for the first time? The race has started, and when do they meet for the first time? Obviously here you are supposed to remember that together they complete one full lap. So for opposite direction for the first meeting, what you are supposed to remember is together they finish one full lap. And now because in same direction we did the difference of the speeds, here we'll have to do addition of the speed. So assuming same ratio of the speeds as 1:5 for both the runners A and B, in this scenario these guys will meet in 1 plus 5, yani they will meet in 6 different points, and they have to be 6 symmetric points, something of this sort. As usual, the last meeting, in this case it is the 6th meeting, that will happen at the starting point. The 6th meeting that will happen at the starting point. So opposite direction for the first meeting, together they complete one full lap. Whatever is the ratio of the speeds, we have to take the addition of that. These many points they keep meeting, they all have to be symmetric points on the entire race track. And the last meeting, in this case it is the 6th meeting, that will happen back at the starting point. So these are the pointers that you are supposed to remember as far as question solving is concerned in terms of circular races. Now the same thing has been generalized in a generic format. So suppose ratio of speeds in the reduced form of the runners is A is to B, assuming A is greater than B, and if they run in the same direction, they will meet in A minus B points, and every A minus B meeting will happen at the starting point. If they run in the opposite direction, they will meet in A plus B points, and every A plus B meeting will happen at the starting point. So same thing that we did earlier in terms of numerical values, now they are giving it out in a generic format. One last thing, whether it is same direction or whether it is opposite direction, one simple common part was that for the first meeting, if you had observed, in the same direction we said that for the first meeting the faster runner will have a lead of 1 lap over the slower runner, and for opposite direction we said that together they complete one full lap. So what does that tells us is that if it is the same direction or if it is a opposite direction, it doesn't really matter, and this is applicable only for the first meeting. The time taken to meet for the first time is given by a simple formula of relative speed, which is separation upon relative speed, which we did in the previous topic of time, speed, distance. But in this case, the separation between them for the first meeting will be one full lap, which is the entire circumference, and hence this is a generic formula which is applicable in both the cases. Time for the first meeting is given by circumference upon relative speed, and as usual then the relative speed will by default have its two scenarios. Objects are running in the same direction, objects are running in the opposite direction. Same direction you subtract, opposite direction you add. So these are the things as far as races are concerned. The last part from this particular topic is basically clocks. It's a very simple idea. Obviously it is also a circular race between a minute hand and the hour hand, obviously in the same direction. Now here we are going to explore a couple of new units. One of them is either in degrees or in minute spaces. So the entire clock has a circumference of either you say 360 degrees or 60 minute spaces. 60 minutes is basically 60 minute spaces. Now because it's a circular race, same direction, we would require the relative speed, and for that relative speed we require the individual speeds of the hour hand and the minute hand, because once we have their individual speeds, for relative speed we'll just take the difference between both of them. So let's explore that in detail now, and you may remember this as a conclusion, or you don't even remember, that's still fine, because you are able to derive this. It is not that difficult, and we'll explore in both of the units, degrees as well as minute spaces. So the first part, speed of the minute hand, degree per hour. Let's first do per hour, then we'll do per minute also. So minute hand in 1 hour covers the entire clock, which is 360 degree per hour, and in minute spaces it is 60 minute spaces per hour. Speed of the hour hand in 1 hour covers 30 degrees. How do we get that 30 degree? So entire clock is 360 degree, which is 12 hours, and 1 hour becomes 30 degree. Or in terms of minute spaces, in 1 hour, hour hand covers only 5 minute spaces per hour. So these are their speeds per hour. We have to do per minute. We'll have to divide everything by 60. When we divide that 360 by 60, we get 6 degree per minute. 60 divided by 60, 1 minute space per minute. 30 divided by 60, half degree per minute. And lastly, 5 divided by 60, 1 by 12 minute spaces per minute. So these are their individual speeds. And now for the relative speed, because it is the same direction, we are just going to take the difference. So 6 minus half, 5 and half, which is 11 by 2 degree per minute, or 1 minus 1 by 12 gives me 11 by 12 minute spaces per minute. So these are the relative speeds in degrees and minute spaces for the hour hand and the minute hand. You may remember this as a direct thing. Even if you don't, you know that it is not very difficult to derive if required. Now, taking the same thing forward, some common and the general facts about the clocks, the same thing that we are doing so far, but in different words. So be very careful while reading. 1 minute space is how many degrees? It is 60 degrees. 60 minute spaces, 360 degrees, the entire clock. Then they are saying in 1 hour, the minute hand gains dash minute spaces over the hour hand. So for that, first of all, you'll have to individually figure out that in 1 hour, minute hand travels 60 minute spaces, and in 1 hour, hour hand travels 5 minute spaces. Let that sink in. And that means in 1 hour, the minute hand has 55 additional minute spaces over the hour hand. The third point, in 1 hour, the hour hand moves 5 minute spaces, or that is 30 degrees, and minute hand in 1 hour moves 60 minute spaces, or 360 degrees. Then in 1 minute, the hour hand moves half degrees and the minute hand moves 6 degrees. And that means in 1 minute, minute hand has gained 5 and 5.5 degrees over the hour hand. So these are the same things that we know already, but in different words, they are asking the same things. The next part, the standard time of coinciding the minute hand and the hour hand. So obviously this can be given by a formula. Time taken to meet is separation upon relative speed. Separation races है तो circumference if you take it in degrees, then the relative speed will also have to be taken in degrees, which is 360 divided by 11 by 2. If you take the circumference in minute spaces, relative speed is also taken in minute spaces, which is 60 upon 11 by 12. Both the things will give you same answer, which gives me 65 5 by 11 minutes. Mixed fraction mein answer hai. So the point is that hour hand and the minute hand will keep meeting each other every 65 by 5 by 11 minutes. This is their standard meeting time. They should keep meeting each other every 65 5 by 11 minutes if the clock is on time. It's on perfect. And then there can be two scenarios. The clock is supposed to gain time, that is fast, if the clock meets, I mean the minute hand and the hour hand meets each other before 65 5 by 11 minutes. That means they meet in less than 65 5 by 11 minutes. The clock is supposed to be fast. And ulta, if they take more than 65 by 5 by 11 minutes, 65 5 by 11 minutes, then that means the clock is supposed to be slow. So this is their standard meeting time for the minute hand and the hour hand. So very interesting ideas and a lot of new things we learned in terms of concepts, whether it is races, linear, circular, then two types of circular, same direction, opposite direction, and then at the end clocks. So guys, we are done with the P module and this particular topic as well. Please go through this if you have any questions, any queries, and do let us know. We will be happy to assist you. Thank you so much. Hope to see you soon. Bye bye.